Out here, isolation is the first real challenge a builder faces. Before a single wall goes up, a rigid skeletal framework has to be established to anchor everything to the earth. The constant mechanical rhythm echoing across the site marks the installation of the primary metal roof framing. Working with heavy-gauge steel alone is a punishing process of leverage and balance. Each structural strut must be aligned with precise tolerances to ensure the weight of the eventual roof is evenly distributed. Steel offers superior tensile strength compared to traditional timber framing, significantly reducing the risk of warping or rot over the coming decades. The choice of metal over wood for the upper canopy is a calculation of endurance. Rust-resistant coatings on the steel add a critical barrier against the damp forest air. When a solitary builder tackles overhead metalwork, gravity fights every maneuver. Securing these high-elevation joints requires methodical pacing to avoid fatigue. The connections form a continuous load path, designed to transfer the immense crushing force of future wind and snow loads directly down through the vertical supports. A single misaligned beam at this stage will amplify into severe structural defects once the decking is applied. There is no rushing the skeleton. It has to be perfect. The relentless pace continues as the main structural ribs are locked into their final positions. Every drilled hole and driven fastener binds the independent steel components into a monolithic rigid frame. In open-air construction, shear strength is only half the equation. The framework must also possess slight flexibility to absorb dynamic forces, like sudden thermal expansion during the day or high wind shear sweeping across the clearing. By utilizing heavy-duty self-tapping screws and reinforced brackets, the builder creates joints that hold fast while still allowing for metallic micro-movements. This prevents the fasteners from shearing under environmental stress. It is a grueling, repetitive phase of the build, holding heavy steel crossmembers, perfectly level with one hand while driving hardware with the other tests. Both endurance and grip strength. The auditory feedback of the drill sinking into metal confirms a solid bite. Without a crew to hold materials or check plumb lines, the craftsman relies on temporary clamps and an intuitive understanding of weight distribution. Every connection point is heavily scrutinized. A compromised joint overhead could prove catastrophic during a severe storm. Safety here relies entirely on over-engineering the connections. Slowly, the chaotic arrangement of loose steel transforms into a mathematically sound grid. The geometry is finally taking shape, establishing a permanent canopy that will dictate the entire layout below. With the metal grid secured, the focus shifts to establishing the solid overhead decking. The constant reverberations across the frame indicate the heavy panels are being wrestled into alignment. Roofing is notoriously unforgiving work, especially when managing large, unwieldy materials in a slight breeze. The panels must overlap with exact precision to create an impenetrable barrier against standing water and driving rain. Even a millimeter gap at a seam can invite moisture, which eventually decays the living space below. The structural logic here relies on a slight, calculated pitch. That specific angle ensures gravity rapidly sheds water, preventing pooling and minimizing the static load on the trusses. Fastening the panels requires driving screws firmly enough to compress the rubber sealing washers, but not so deep that they warp the surrounding metal. It is a delicate balance of torque. The builder systematically works his way across the span, locking the canopy down one section at a time. The physical toll of operating a heavy drill at an awkward overhead angle for hours cannot be overstated. Endurance is just as vital as technique. It becomes a fortress against the sky. The shelter is finally gaining a true roof. The shadow it casts below is the first real sign of a room. Hours into the roofing phase, the final heavy sections are locked down tight. Completing the canopy completely changes the acoustic environment of the build site, capturing the sounds of construction and reflecting them downward. This barrier is the most critical defensive layer of the entire project. Modern roofing materials are designed to reflect a significant portion of solar radiation, which will keep the space below shaded and cool during peak summer hours. Beneath the metal, the trapped airspace will act as a buffer, mitigating drastic temperature swings. Every edge is meticulously fastened to prevent wind uplift. High winds can turn a loose roof panel into a dangerous sail, generating enough lifting force to tear the structure apart. The builder methodically secures the perimeter, ensuring the drip edge extends past the underlying beams to direct water safely away from the structural supports. Dry footprint is essential for the next stage of construction. With the sky successfully blocked out, the weather is no longer an immediate threat to the interior. The craftsman has carved out a permanent pocket of dry space in the wilderness. The canopy is complete. Safely under the new roof, the construction immediately pivots downward to establish the foundation of the living space. Framing a floor on uneven wilderness terrain requires a complex network of level joists. The structural integrity of everything placed inside the cabin will depend on the rigidity of this wooden subfloor. Using thick, heavy-duty timber ensures the deck will not sag or bounce under a dynamic load. The builder carefully sets the parallel joists, maintaining a strict on-center spacing. This exact spacing is an age-old carpentry standard designed to maximize the bearing capacity of the floorboards while minimizing material waste. Selecting straight, unbowed lumber for the perimeter is crucial, as any early deviation will magnify as the flooring expands. Wood in an outdoor environment is highly susceptible to ground moisture. By elevating the joist system on sturdy supports, a critical gap of airflow is maintained beneath the deck. This ventilation prevents damp earth from rotting the timber from the bottom up. Securing the heavy planks involves driving massive fasteners through the dense grain, a process that requires considerable torque and steady downward pressure. Each hammer strike or driven screw pulls the wooden framework tighter together, utilizing friction to increase the overall shear strength of the floor. The chaotic unevenness of the wild earth is systematically being erased, replaced by a perfectly flat, level plane of engineered wood. The foundation of a civilized space is taking root. The relentless pace of framing the floor deck presses on as the grid of lumber expands. The structural diaphragm of the floor relies on a staggered layout. If all the seams lined up perfectly, it would create a continuous weak point across the deck, prone to splitting and settling. By offsetting the joints, the builder forces the load to distribute across multiple spans, dramatically increasing the rigidity of the entire platform. Working near ground level places immense strain on the knees and lower back. The constant up and down movement of retrieving materials, measuring cuts, and driving hardware is an exhausting physical loop. Yet, the work cannot be rushed. A floor that is out of square at this stage will complicate every subsequent phase of the build, from installing walls to placing furniture. The dense timber absorbs the shock of the heavy impacts, locking the fasteners deep into the grain. As the structural webbing nears completion, the raw framework resembles a massive wooden raft floating just above the forest floor. The primary living zone is now clearly defined by its solid borders. It is a heavy, permanent anchor. By the next afternoon, the focus shifts to an ancient method of outdoor paving. Using cut log slices, often called cordwood paving, creates a durable, weather-resistant patio surface. The man shovels fine, loose soil directly over the wooden rounds to act as a natural grout. This earthen filler locks the circular logs firmly into place, preventing them from shifting or rolling underfoot. As the soil settles deep into the crevices, it binds the individual logs into a cohesive, solid floor that breathes with the landscape. With the structural hardscaping complete, the builder turns to outfitting the space. Crafting a utility table from dimensional lumber and raw logs requires blending precision carpentry with rustic materials. He aligns thick wooden planks to form a heavy-duty tabletop, relying on traditional nail-driven joinery for sheer holding power. Using freshly cut, raw logs for the table legs is a deliberate choice. The dense, natural grain of the round wood can support immense vertical weight without buckling. Nailing directly into end grain can be tricky, as the fibers tend to split, so the hardware must be driven straight and true. Kneeling in the open grass, the craftsman uses the ground itself as a massive, flat workbench to keep the top level while he works. The heavy blows of the hammer seat the metal deep beneath the surface of the wood, creating a rigid friction joint. This isn't fine cabinet making. It is robust, functional engineering meant to survive heavy outdoor use and seasonal weather changes. The finished piece is brutally strong. A stiff, bristled broom forces the remaining soil deep into the narrow voids between the patio logs. Sweeping away the excess dirt reveals the rich end grain of the wood. The tightly packed earth now functions as a dense, locking mortar, permanently stabilizing the floor. Positioned under the shelter, the heavy wooden table receives a protective coat of finish. Untreated wood left exposed to fluctuating outdoor humidity will rapidly warp, splinter, and decay. The sealant penetrates deep into the porous grain, creating a waterproof barrier that locks out moisture and prevents rot. Applying the finish with a heavy brush ensures the thick liquid works its way into every rough, saw mark, and micro fissure. He moves on to seal the perimeter railing, reinforcing the gazebo's defenses against the damp environment. The raw materials are finally secured against the elements. The space transforms from a mere shelter into a functional outdoor kitchen. Driving a mount high into the structural rafters requires carefully avoiding the critical load-bearing joints of the timber. The mounted skull serves as a traditional hallmark of a wilderness camp. Heavy cast iron cookware is suspended directly from the overhead beams, utilizing the vertical volume of the gazebo to save valuable workspace below. Cast iron is heavy, requiring thick steel hooks anchored deep into the structural wood. Storing the skillets in the open air keeps them dry and ready for immediate use over an open flame. The outdoor kitchen is now fully operational. Hours later, the grueling labor yields its final reward. A hot meal prepared on a hand-built table, eaten beside a stone fire pit, changes the entire psychology of the site. It is no longer just a construction project. It is a functioning habitat. In the end, structure, landscape, and daily routine operate as one system. It is a quiet place that produces, protects, and sustains itself.